Hello everyone, welcome to the data migration demonstration course. We will demonstrate the entire migration process from Oracle to GhostDB. This course contains two parts, UGO service operation demonstration and DRS service operation demonstration. First, the part is the UGO service operation demonstration, which is to help you have a brief understanding of how to use UGO to migrate your database objects and applications. This demonstration has two parts. First, it introduces the end-to-end migration process of the UGO service. By learning the end-to-end migration process, you can master the migration methodology and clearly understand the purposes and results of each step. Secondly, I will demonstrate the use of UGO service. This demonstration uses the migration from Oracle to GhostDB as an example. First, let's look at the overall UGO service usage process. The overall process consists of two end-to-end processes. The first step is to migrate database objects. You need to create a database evaluation project. The main purpose of this step is to collect original database objects and perform evaluation of compatibility between databases based on the collected objects. After collection and determination of the target database, you can create an object migration project. In this step, you can convert the syntax and literally migrate to target database. Notice that both of the syntax conversion and the migration may fail. You need to correct the objects and verify the migration of the converted SQL statement in the destination database. After that, you can optionally create an object comparison project if you want to roughly compare the result of the migration, which only compares the number and key attributes of database objects. The second end-to-end migration process is application migration, which mainly extract and convert SQL statements in service code. You can upload your application code zip. UGO will help you find and collect the SQL statements, and the evaluation and conversion process are just like that in object migration. The only difference is that the result of the migration of objects lay in the target database, while the migration of application is a zip containing the modified code files with the same structure as that you uploaded. So, let's do a hands-on demonstration of the UGO service. So, let's start the practice. And we'll start with schema migration. Before we start a real migration, we have to know that what we have to migrate and how well they can align with the target database. UGO gather the two steps together, which called DB evaluation. So let's create an evaluation project. In this step, we need to fill in the source database information for UGO to connect with. Let's fill in the project name. For collection time, you can choose to start instantly or schedule the task by time segment. We'll just do it instantly. And we want UGO to help us evaluate the database compatibility and migration costs, so we do not skip evaluation. We'll demonstrate an Oracle to GhostDB migration, so we choose Oracle. UGO offers two ways to fill in the connection info. We choose to do it step by step. And we have to test if connection can be successfully established. Good. Since UGO can establish connection to source database, we're ready to go to the next step. This phase is called pre-check, verifying the minimum required permission for objects collection. If it didn't pass the pre-check, we need to log into the Oracle to grant the minimum permission with the direction. Next, the object type selection. We need to select the objects we want to evaluate and migrate, and we select the target DB. GhostDB will migrate to GhostDB, but let's add Postgres for comparison. We don't have the dynamic SQL, so we disable the evaluation, and we can choose the schema we want to migrate. Next, confirm our information and create. Now we have finished the evaluation task creation. Click OK and we come to the list of evaluation tasks. We can see the evaluation progress running in the background. We can stop when we've found out some wrong configuration, and we can also click trace to see if there's any error occurs. Let's wait for a little while. Okay, it's done. The status is still in progress because there's one last step. Let's click the Confirm Target DB. There are two reports. One is the report for GhostDB, and the other is for PG. We can download the report, but the report is basically the same as shown on the screen below. Before we select the target database, let's have a quick view of the report. GhostDB supports all of the features that we collected, so let's take a look at Postgres report. The first part is a migration cost estimate. There's too little not supported object in source database. Thus count out to be a really little number. The second part is support statistics. Move our mouse over the bars. There are 4 statuses. Native supported counted the objects that are grammatically equivalent. And UGO supported means for these objects, there may be some different grammar, but can be converted semantically equivalently. Supported objects with risks counted the objects which are possible to make the conversion, but under certain circumstances, the conversion is not equivalent. UGO offers multiple conversion options for this kind of scenarios. There are 2 cases for unsupported. One is that there is really no solution that you need to reconstruct your application. The other is that the object cannot be converted automatically. The solution may depend on complex context and need to be converted manually. The unsupported is the red part of the bar. The table below shows the unsupported syntaxes and partially compatible syntaxes, which are those supported with risks. We can check the details. We can see that Postgres does not support dblink and synonym. And below are some keywords not supported, and partially supported features that can be handled by setting corresponding configurations. But there are always some restrictions for each choice. From the report, we can see clearly that GhostDB is more compatible with Oracle, so we choose GhostDB. Before we confirm the selection, let's take a look at the source database. There are some basic information on the above and the object statistics below. We can click the View Object Details to see our objects. On the left hand is the object tree, and on the right hand is the object list. We can filter them with names. For example, we search generated, and there goes tables containing generated, and we can check the details. So let's go back and confirm DB selection. By now, we have finished the evaluation progress and can start migration. We go and create a task now. Let's fill in the target PG info. Same with evaluation, we test connection. Next. In this step, UGO will check the char set and the compatibility mode. Next, create. In the background, UGO will check the create object permission. Okay, it's ready. Let's do the migration. The first step is to make a migration plan, selecting the objects that we want to migrate. There may be some objects that cannot be compiled in the source database, or in some cases, the target database does not support overload functions, or you just have some deprecated objects that you do not want to migrate, we can mark them as skip. We can use the object tree or searching filter to locate your object. If we have collected the users in the source DB and are planning to migrate them with UGO, we have to identify the users with new password, which will be encrypted in the background. Next is the feature conversion configuration. For those objects who have risks for migration, we need to choose our solution. We can see loads of configurations and selections for each of them. For real practice, this step is essential. We have to determine how to convert those features carefully. But for demonstration, let's just skip this part. And for Oracle, we have to map the table space. We just choose the default table space. And next, let's click Start to start the DDL conversion. We can see from the statistic that one of the object conversion have failed. Let's check out why later. Okay, let's check the details. It says max value option does not support value greater than the number on target database. You can see the source object. The maximum value set in source object is really large that GhostDB does not support. We can either fix the number on the right hand manually, like this, or if we have a lot of objects like this, we can use the configuration. Let's go back to the configuration. It's a sequence. So let's search sequence. If we are sure that we really need that big a value, we can use the large sequence. Okay, so let's do the conversion again and see what will happen. If the conversion didn't meet our expectation, we can do this again and again. But beware, the conversion will override your previous conversion, especially when you have already done some manual modification. We can see the sequence is converted successfully. If we want to migrate data after we have done object migration, we always want the migration processes as fast as possible, especially when we have massive amount of data. So we can leave the index or other objects skipped, like this. Oh, like this. So we can leave the index or other objects skipped and migrate them afterwards, like this. Skip. We can see they're all success. So let's just start migration. In this step, UGO sends all of the converted DDLs to target database. Let's verify the result by taking a comparison. Let's select the migration project we have just finished. We can see the information of both of the source and target DB. And test the connection. Because we only migrated this one schema, so we choose the schema that we selected before. Next, create. Okay, it's done. Let's check the report. We can see most of the objects are successfully migrated. Let's check out which object failed and what attributes are taken into consideration. For procedure, you can see it match the procedure name, owner, deterministics, and parallel, auth ID, and overload attribute. And we can see the auth ID is different, which is fully acceptable. And for the failed function is the same, it's the auth ID. Beware that even if the success rate reached to 100%, we also need a detailing test in case the behavior or performance is out of the expectation. That's all for schema migration. And next, I'll demonstrate application migration. Let's create a project first. And upload the source code. And we'll migrate to GhostDB. Okay, it's done. The first tab shows what we have in the application. 31 create, and 3 misc, 19 comment, and so on. And on the right hand shows the statistics. Below is the SQL list. We can view the details extracted from the source code. The second tab categorized the SQLs into an object tree and list the SQLs with more details. Let's take a view. We can see the source SQL and call stack, which tells where the SQL is extracted from, and the history we modify it. For some SQL that's not necessary, we can delete them from the migration. The third tab is the evaluation report, which is the same as that in schema migration. We just skip the analyzing progress and just confirm the target database. And go to conversion. On the left hand shows the file that contains SQLs. We can switch between files to consider less SQLs in one time. Start conversion. We can see from the result list that most of the results are native supported, which we don't need to pay more attention. Let's check within the random file and view an unsupported SQL. Obviously, this is a MyBetis mapper XML. UGO provides a code editor and divides it into 4 parts. The upper left is the source file, and UGO locate the target SQL for us, while the lower left contains the extracted target SQL. UGO extract the SQL from complicated MyBetis for each iteration. The lower right shows how the Oracle syntax on the left hand converts to. Feel free to edit the 2 editors below. They will not affect the final result. What we really want to do is to write correct MyBetis code in the upper right editor. Let's check out what's happening. It says insert statement does not support multi-insert clause. We can split the single insert into multiple insert statement and execute it. In this case, UGO automatically conversion doesn't work, so we have to rewrite the SQL manually. GhostDB does not support insert all, so we insert each of them. We can also open the comparison mode to see which has been modified, and we can save. We'll not demonstrate editing every SQL. Just assume we had done all of the modification. Let's export the source code and check the result in the zip file. You can see the directory remains the same structure as before, and we can find the modified SQL here. Okay, that's all from application migration. Finally, let's take a look at the overall database migration process. Step 1. Use UGO to migrate the database objects. The ultimate objective is the success rate of object migration reaches 100%. And as long as there is no reduction of the number of objects and the key attributes of the objects are not changed in the object comparison, the database objects are successfully migrated. Step 2. Use UGO to migrate the SQL statements in the service code. In Step 3, use DRS to migrate data. You will learn about the details of DRS in the next part. Step 2 and Step 3 can be performed simultaneously because DRS can migrate data as long as you have finished object migration in Step 1. Step 4. Perform a lot of verification tests to ensure the accuracy of the final migration.
Okay, after finishing the application migration for UGO, let's take a look at the third section, which is operation demonstrate for DI service. In this lessons, we will create a synchronization task from Oracle to GovDB on the DIS console to show you how to use the DIS service. First, let's introduce the DIS service. Basically, it's about where DIS stands and what it can do. Then we explain how DIS works in a simple way so you can see how DIS transfer data. Finally, we will walk you through setting up a task which is from Oracle to GovDB so you can get more familiar with how to use DIS. DIS is self-developed translation service for transfer data between databases. It supports various database agents and covers most of mainstream databases in the market. Those databases are used as the source and target link in a cross-linkage of data synchronization. DIS supports various synchronization and isomerism data flow scheme. Next, let's see how the DIS service works. This is complete for diagram of the DIS running phase. Let's look at it from left to right. The overall synchronization task have 5 stages. The first stage is performing structure migration. DIS mainly creates table structure information on the target end, including primary key and view key to ensure that data can be written to the target database normally during the full migration phase. Of course, we also recommend you to use a UGO to replace this part. Additionally, we can uncheck the synchronization structure of operation in the DIS setting page at this time. The second stage is to transform all data through the clone stage of DIS. During this progress, data that need to be synchronized from the source end will be extracted, so the time depends on the size of the data that need to be synchronized from the source database. At the same time, before the formal migration of DIS will have a long factoring progress to download the source database logs and cache them on the DIS instance node to ensure the DIS can get any new business change added to the source database during the full migration stage. After the full migration is complete, the incremental migration playback will begin in the startup phase. This is the key to ensuring the business is not interrupted during the synchronization progress by DIS. After full migration is complete, we move on the third stage. In this stage, other objects like index and views are filled in. The fourth stage is the incremental migration stage. There will be 2 parts. Part 1 is to replace the incremental data that DIS cached during the full migration. At this point, DIS tasks are the incremental central stage with a certain delay. Once the full migration's incremental data is replayed and synchronized completely, the second part of incremental begins. This is a real-time synchronization of incremental data. At this point, DRS tasks are in the incremental synchronization, and the delay is usually within a small range. In theory, the source database and the target database data are completely the same, so we can start a comparison task for data. The last phase is when we are sure we don't need the data synchronization anymore, we can click a button on the page to end the task. During the task ending progress, DRS try to migration for those trigger events and other objects that might affect the incremental data from the database. Once this is done, DRS-related instance resources are released. Okay, now I will show you how to create a real-time synchronization task from Oracle to GaussDB. So first thing you should do is log into the DRS console and click the button on the left, which is Data Synchronization Management here. So click the Create Synchronization Task here, and well, here was the task name, and you should choose Oracle as your source, and choose GaussDB as your target right here. So you should enter in the EIP. If you don't have, then create a new one. Then choose the TalkDB right here. And also you can choose a synchronization model, and I choose a 4 plus incremental here. Then you can click create now. And well, this takes a little bit time, like here. So it shows this operation takes about 5 to 10 minutes. So you just need to wait. So let me use the created task as an example here. So after you wait like 5 to 10 minutes, then you find out that it shows the synchronization instance created success, and here was its EIP here. And you need to add this EIP to the source data whitelist so that it can access the source database. Yeah. Then you need to enter in the source database IP address and port and the server name and database username and database password here. If you have the SSL connection, then you can open this button and upload some file, and then you can just do the test connection here. Okay, so here was also the same, like entering the username and the password, then plus the test connection. After the connection test is done for both the source and the target one, then you can plus the next here. Here was a notice and plus agree. Okay, here was the synchronization task page, and here was about the you can choose the synchronization object here. Here was the tables, and let me choose one as the example. Okay, I choose this database here. In this part, let's choose this table. Okay, then move it to right here. Then here was the database I want it in the target in the target database, and I can click the edit, so it have a new schema name, for example, yeah. So here was another kind of things, and I don't do much more here. Okay, so plus the next. So in this page, I choose one table here, the T1 as an example, and plus next. Here was another page. So for the four synchronization settings, you can set for incremental capture and incremental playback. In this area, you can select the type of for object to be synchronized by DRS. For example, you can enable the DRS to synchronize object structural information and index information. This and this. The data is selected by the default by DRS. You can also set the number of concurrent export and import data. Here, this two number is the concurrent exportation task, and it means the number of the thread read by the source database here. And another number is about the number of playback operation thread in the target database. In addition, the larger the number of those, the greater the pressure on the source or target database. In stream model, a task sharding is synchronized by an export thread, and after the sharding is complete, the data is submitted once. In no stream model, a shard is synchronized by one export thread and multiple import threads. The size of shard is submitted based on the data import cache. By default, the shard is submitted after the data import cache is complete. In this example, the stream model is select. Yeah. And next for the import model, the options are copy and insert. The copy is a high performance interface in COSDB. It has a high import rate but low cost. So another thing is that you can set the number of concurrent capture and the number of incremental playback. The incremental playback policy and incremental conflict policy on the target end are optional here. Okay, so let's plus the next. Okay, here was a new page which is process data. So here you can processing the column. For example, let me take this one as a example. So the C1 is the primary key, right? So if you want it to get a new column name, you can plus edit here. Then you can enter in the new column name, right? For example, and plus OK. So it was done. But if you don't want it, then move back to the left right here. Okay, another part is about data filtering here. So let's take this table also as an example. And so first thing you need to do is move to the right. Then you need to input in the filtering condition here. For example, the CE is used as a primary key. For example, you only need to synchronize the data whose CE is smaller than 1000, then you can write like this, CE lower, you don't need the CE more than 1000, and then plus this button. After this is done, then click here, general the processing rule. Then this rule is done. But if you don't want this, then click the delete. Yeah. Okay, so let's move to the next page here. On this page is the Pro Checker page. You can view many Pro Checker items. The function of this check item are different to improve the success rate of the data synchronization. If some items do not meet the requirement after the modification is success, you can click the recheck here. Also, you can, based on the error information, the results as follow: passed, failed, or not start. If you see the startup failure is basically because of some previous check item fail. So for example, the cause of the startup failure is whether the permission of a target database is enough. This simple check item fail means your previous part is wrong, right? So now those check is complete. Some check item pass the check. If the check item fail, you need to confirm the check here. So there was some confirming you need to check, and there was some suggestion. If you think there was no risk, then click OK. After confirming all this item to be confirmed, click Next to start the task. Before starting your task, you can view the configuration information about the source and the target database, such as connection address and IP address. Then you need to click this here to submit. Okay. Then let's back to the list, task list right here. Now you can see your task is starting. Then you can click the task to view the task detail right here. So it shows the for and the incremental synchronization information is displayed. During the task startup, it will load the task structure information and the source data information of the source, and do some analyze configuration. So it takes about 3 to 10 minutes. In addition, you can view the four-shot information like here, the synchronization progress. So it was waiting for the full synchronization, right? Also, you can view the progress information here, configure on the task. Another thing is progress data. There was no filtering condition, so this was empty. Okay, then you can plus the synchronization map. Okay, here was empty too. So in this part, you can see the map information, and you can also view some task logs here. For example, here was we just do the pro checker and there was total 31 item, and the 30 items is success, right? So let's move to synchronization progress. Okay, so there was also another, which is abnormal record here. So you can view some abnormal data related to dirty data caused by the U-key constriction on the target or other condition during the synchronization. When the task is incremental, you can click synchronize and compare to synchronized data. Yeah, right here. So the synchronization and the comparing function, including object level comparison and data level comparison. Okay, so let's just wait till this was done. Okay, now the task has reached this incremental stage. Let's make a data comparison. So first, you need to create an object level comparison here, then plus compare right here. So the data level comparison include the row number comparison and the content comparison. So we can see here is the same. Then we can do another comparison, and I just do this. Let's view the result here. So plus view the detail. So we can see the table, which is T1, and the rows is 10, which is the same on the target, right? Okay. So let's back to the list. Okay, as we can see, there was some delay. So let's try now. The T1 has those value. Let's do some insert. So here we do 3 insert, right? And let's see here. So here was the target one. Okay, let's find this one right here. Okay, the T1, right? So let's selection from T1. Okay, let's see. The 3 insert was done right here. Okay, so we can do another synchronization comparison for a data level comparison. Yeah, so we click here. Let's see the result after we do 3 insert, right? So the source and the target rows is both 13, right? Okay, so let's back to the list. Okay, so there was another function I want to introduce. Is about the we're adding here in incremental synchronizing task, click edit button to edit the synchronization object information. Yeah, for example, if the current tasks synchronize only the T1 and you want to add more, then you can choose here. You can choose another one and you can do the mapping, for example, like this. Okay, then click next. And here was another processing page here, and you can do for the one you add. Yeah, and also on the previous one, you can also put the T1 back to here. So it's also okay, right? Then plus next. Then after do the project, then you start it, then it will have a subtask. So after it's finished, the object will be added to this task. Okay, to sum up, a complete DRS synchronization task have those phase. So first thing you need to do is to create a task. You need to apply for a DRS task instance on console. Next, you need to test the connection. You need to enter in the connection information of the source and the target on the page. Then you need to select objects. In this case, you can choose the objects in the database of the source and on the console. In this case, you can select the object to be synchronized on the page and map the table names of the mapping lib to the target end. The next step is to data processing. So in this case, you can perform rows and column filtering and column name mapping on the page. Step 1 to 4 are the task configuration phase. The project is step 5. The pro checker before the task start, which is used to improve the success rate of the data synchronization. Start the task. Tasks are start in the full synchronization and incremental synchronization. Full synchronization synchronize the data on the source end, and incremental synchronization do the new data on the source end in the real time. When task entering the incremental synchronization state and the page latent is low, you can compare the data on the page. Data comparison include object level comparison and row number cooperation, which is used for data verification. So when the DRS task is in the incremental synchronization state and the data result is the same, then the DRS synchronization task is complete. The data on the source has been synchronized to the target. In this case, you can stop write Oracle service on the source and connect the service application to the target end. After the DRS task is complete, the data migration progress is complete. If you have any question about the database install and migration, you can find us. That's all. Thank you for watching.